What's up guys? So we are doing 1.2 line segments, fractional distance, and midpoint. So we're basically taking three things and combining them into one lesson here. So what you need to know first is if you look right underneath your vocabulary, right where it says postulate, you're going to write in this postulate. We are doing something today known as a ruler postulate. And what the ruler postulate states is, to measure the length of a segment, you can use a number line to count the distance between the two endpoints. So just like you would count from one point to the next, that's what you do on a number line. So right here, on example number 1, down the bottom here, it says find the distance between -2 and 6 on a number line. So I'm physically going to draw a number line here. Okay? I'm going to go ahead and put 0 right in the middle. So obviously, -1 goes before 0, then -2, then 0, you got 1, you got 2, you got 3, you got 4, you got 5, and you got 6. So now literally what I'm going to do is what it told me to do. Find the distance between -2 and 6. So I'm going to start at -2 and I'm going to count over to 6. So 1, 2, 3, 4, 5, 6, 7, and 8. So the distance between -2 and 6 would obviously be 8. Alright, so now on example number 2, we're given another number line, and it wants us to find the measurement of PQ, of QR, and PR. And so we're literally just going to use the ruler postulate here where to count it over. So it looks like right here going from P to Q. So on P, it looks like I'm sitting at -3.5. And then on here, I'm sitting at -2. So physically here, I'm going to count over to -2 and see what it's going to be. So right here going to -3, that's going to be a half. Okay? And then I'm going to go to -2, which is going to be a 1. So that is going to be 1.5. So the difference from, or the distance from P to Q is going to be 1.5. So next I'm going to do from Q to R. So it looks like Q is sitting on -2, and R is sitting on positive 2.5. So I'm going to count all the way over till I get to 2, and then I'm going to count that extra 0.5 to make it work here. So let's go ahead and count. So starting from -2, I'm going to count over. So I'm going to go 1, 2, 3, 4, and then a 0.5. So the distance from Q to R is going to be 4.5. And now lastly, I'm going to do the distance from P to R, and I'm going to literally just count again. But on this one, it looks like both of these are sitting on 0.5, so I'm going to count my 0.5s here. So I'm going to go on the bottom here. So starting from P, I'm going to go from -3.5, I'm going to go 1, 2, 3, 4, 5, and 6. So the distance from -3.5 all the way to 2.5 is going to be +6. And that's how you use the ruler postulate. Alright guys, so now if you look on the back of your paper where you see postulate 1-5, that's going to be the same ruler postulate. So previously I taught you guys how to basically count over, and now I'm going to show you mathematically how this works. So instead of going from point A to point B and counting all the way to point A to point B, you may have a distance that's tremendously huge. So in order to do this, I'm going to go ahead and show you how to mathematically do this. So to find the distance of line segment AB, that's going to be equal to the absolute value. Absolute value means no matter what happens in here, this is going to always turn back to positive. So I'm going to find the absolute value of what A is minus what B is. So right here in this instance, I would plug A in for the first one. So A is -2. And then B is going to be +5. And so now I would just work this out. So -2 minus 5 is going to be -7. The absolute value of -7, remember I told you the absolute value bars are going to change to positive. So the distance of AB is going to be +7. Alright guys, so now I'm going to use what I just taught you to find the distance of PM, the distance of LN, and the distance of RM. So remember I just showed you to find the distance between 2 points, I'm going to use it as D, that's going to be equal to the absolute value of A minus B, or whatever the two coordinates are, that's how I'm going to plug it in. So right now I need to find P to M, so that means I want to find the absolute value of P minus M. So the absolute value of P minus M. So right now if I look here, P is at -4.5. So I'm going to do -4.5 minus what M is, which is going to be -3. So minus -3. So we got a double negative there, which is going to end up turning into a positive. So I'm going to end up doing negative 4.5 plus 3, which is going to end up being negative 1.5. So the absolute value now of 1.5, remember I told you the absolute value bars are going to change into positive. So the distance of PM is going to be positive 1.5, because remember, distance is always measured in positive. Okay? So now let's look at Ln. So looking at L to N, so that means I'm going to do L minus N. I'm always going to go left to right here. I'm always going to find the absolute value of it. So I'm going to do the absolute value of L minus N. So it looks like L is negative 1, so negative 1 minus N, which N is sitting at positive 5.5. So negative 1 minus 5.5 is going to give me negative 6.5, because they're both negatives. And then the absolute value bars are going to change into positive. So Ln is going to equal 6.5. And then lastly, we're going to do the same thing with Rm. So it looks like R is going to be sitting at positive 0.5. And I'm just going to go ahead and do this right here. So 0.5. And then I'm going to be subtracting what n is, which is negative 3. Okay? So it looks like we got a double negative there, which is plus. So 0.5 plus 3 is going to turn into 3.5. And the absolute value of 3.5, remember, it's always going to come out positive. So the distance from R to M is going to be 3.5. Easy as that. Alright guys, and next we're moving on to other parts of these line segments here. So the first thing that you have at the top of your paper says, remember, we found distance by taking the absolute value of A minus B. So whatever your 2 points were, I found the difference of it and took the absolute value of it. So now if I was given a line segment and I wanted to find the middle of a line segment, I would use a midpoint formula. And so basically what I'm going to do with the 2 points is I'm going to take those 2 points, I'm going to add them together, and then I'm going to divide it by 2. So let's say I had positive 2 and positive 6 as my 2 points. I would add those together to give me 8 and divide it by 2. That means the distance between 2 and 8, or 2 and 6 is going to be 4. Okay? And then also we're going to learn something called fractional distance. So we're actually taking the distance between 2 points, but we want to find a fraction of that, and where is that going to fall? So like if I had the distance between 2 and 6, I want to find 1/4 of that. I would multiply by 1/4, and this is the formula. So fractional distance is going to be known as, I'm going to take the first point, which I'm going to recognize it as A, okay? Then I'm going to add K. K is going to be your fractional distance, okay? And then I'm going to multiply that by the original distance formula, which is A minus B. So that will end up turning into multiplication, and this is your fractional distance formula. Alright guys, so let's go ahead and narrow in on our examples here. So on example number 1, I'm given 2 different examples. And what I need to do on A to B and C to D is I need to find the midpoint of those. So I remember, I'm going to take the first coordinate, I'm going to add the second one, and I'm going to divide them by 2. Okay? And that's all I'm going to do. So on this one right here, I'm going to take coordinate A, which is negative 3. Then I'm going to take coordinate B, which is 5. I'm going to add those together. Then I'm going to divide it by 2. So negative 3 plus 5 is going to give me positive 2. 2 divided by 2 is going to be positive 1. So that means the midpoint between negative 3 and positive 5 is going to be 1. So this right here is going to be your midpoint. Okay? And now we're going to do the same thing down here with C and D. So right now, C is negative 7, so I'm going to take negative 7 and I'm going to add it to D, which is positive 3, and then I'm going to divide that sucker by 2. Okay? So negative 7 plus 3 is going to end up giving me negative 4. So I'm going to get negative 4 divided by 2. Negative 4 divided by 2 is going to be negative 2. So that means the actual midpoint between negative 7 and positive 3 is going to be negative 2. So this guy right here is going to be your midpoint between negative 7 and positive 3. So ladies and gentlemen, that is how you find the midpoint. Alright, and lastly here we're going to look at examples for fractional distance. So let's go ahead and remember, fractional distance is going to be the first coordinate plus k, which is my fractional distance, multiplied by the absolute value of a minus b, which is going to be the distance formula basically. So let's go ahead and do this with E and F here. So it looks like E is sitting at negative 7 and F is sitting at positive 1. So I'm going to work from left to right here. So basically E is going to be negative 7, that's going to be my beginning point. So the distance between those, I'm going to do it over here, which is going to be negative 7, plus K, which is going to be 3/4, because I want to find 3/4 of a distance between those. And then I'm going to multiply that by E minus F, so negative 7 minus 1. Negative 7 minus 1, okay? And so now I'm going to do what's in the absolute value first. So negative 7 minus 1 is going to give me negative 8. But remember, I told you when it comes out of the absolute value, it's going to be positive. So it's going to be positive 8. So I'm going to have negative 7 plus 3/4 times 8. Okay? So 3/4 of 8, if I multiplied those together, would give me 6. So I would come out to be negative 7 plus 6. Negative 7 plus 6 is going to end up giving you negative 1. So when I work that fully out, 3/4 of the distance between E and F is going to be negative 1. So that's going to be 3/4 the distance between those. So now let's go and look at the down here. So I need to go ahead and find 1/5 of the distance between G and H. So I'm going to do that between negative 8 and 2. So let's go ahead and get started. So my beginning point is going to be negative 8, so that'll be A in the equation, plus K, which is going to be my fractional distance, multiplied by the absolute value of the distance formula, so negative 8 minus 2. So negative 8 minus 2 of my absolute value bars is going to be negative 10. But remember, I told y'all when it comes out, it's going to end up being positive. So it's going to be positive 10. So that'll be negative 8 plus 1/5 times 10. So if I multiply these together, 10 divided by 5, when I multiply those, it would come out to be that way, would end up being 2. So I would get negative 8 plus 2. And negative 8 plus 2 is going to end up being negative 6. So right now, 1/5 of the way is going to be negative 6. So 1/5 the distance from negative 8 to 2 is going to end up being negative 6. And so ladies and gentlemen, all you have to do is take what you know, plug it into the formula, and then you got your work cut out for you.